Hi guys, hope you're doing well. I am starting lesson 29, session 4, and I am on page 617. And today's session is all about word problems with mass and weight, so how heavy stuff is. So I will zoom in a little bit and let's get started. So it's a very long and pretty complicated problem. It sounds confusing, but once we break it down, it'll feel much easier. So here we go. Kyle has a jar filled with quarters. The empty jar has a mass of 400 grams. Highlighter. So empty jar, when it's empty, it has a mass, so it weighs 400 grams. The same jar filled with quarters has a mass of 1.5 kilograms. So when it's full of quarters, it's 1.5 kilograms. If each quarter has a mass of about 5 grams, so 1 quarter weighs 5 grams, how many quarters are in the jar? Okay, so that is a long, complicated problem. They do give us the conversion hint that 1 kilogram equals 1,000 grams. So our first step, let's see, I'm gonna just, because it's such a complicated word problem, I'm gonna make some notes here on my side first. So, empty jar. Empty jar weighs 400 grams. Just a G for grams, lowercase g. So when the jar is full of quarters, it weighs 1.5 kilograms. So the full jar, 1.5 kg for kilograms. But I want to convert that into just grams so that I can compare it to the empty jar. So 1 full kilogram right here equals 1,000 grams. So 1 kilogram right there equals 1,000 1 kilogram equals 1,000 grams. So this 0.5, half of a kilogram is going to equal half of this much. So that would be 500 grams. So 1.5 kilograms equals that together, 1,500 grams. So the full jar weighs this much, the empty jar weighs only 400. So I need to figure out the difference. So what's the weight just in quarters? Okay, so if I can take away the weight of just the jar, what's left will be the weight of the quarters. So I'm going to do 1,500 minus just the weight of the empty jar. So 0 minus 0 is 0, 0 minus 0 is 0, 5 minus 4 is 1, bring down that one. So 1,100 grams is the weight of all the quarters. So all the quarters in this jar weigh 1,100 grams. But they are asking me how many quarters are in the jar. And they told me that every quarter, so 1 quarter equals 5 grams. So I need to divide. I'm going to take the weight of all those quarters divided by 5, and that's going to be how many quarters in the jar. So number of quarters in full jar. Sorry for cutting that off. Bigger. Okay. So I'm not going to count by fives all the way to 1,100. I'm going to do an area model, or you could do partial quotients, whatever your favorite strategy was for that. I'm going to put my dividend up in the top corner, my divisor on the outside. So I'm going to look at how many groups of 5 can I take from 1,100. I can't take 5 out of 1, so I'm looking at this 11. 2 numbers left over. So how many 5s can go into 11? That would be 2. 2 numbers left over means 2 zeros. So that's 200 groups of 5 that I'm taking away from 1,100. 200 times 5 is 1,000. So I subtract, and what's left is 100. Okay, so I bring my 100 up here. And how many 5s can fit into 100, or how many groups of 5 can I take away from 100? And I know that 20 times 5 equals 100. No remainder. I add my partial quotients up on the top. 200 plus 20 is 220. So my final answer is 220 quarters in the full jar. Done. Moving on. Okay. On the back page, here's the same problem. They used pictures to help understand the problem a little better. So here they show 1/4 and its mass was 5 grams. Here's the empty jar that weighed 400 grams and the full jar of quarters that weighed 1.5 kilograms, which we converted, and we know that that weighs 1,500 grams. Okay. On the bottom, they also used a bar model to help them solve the problem. So they're using the variable n to represent the number of quarters. They say the mass of 1/4 is 5 grams, so the expression, the equation, 5 times n represents the mass of the quarters in the jar in grams. So here, the full bar is the full jar. That rhymes. The full bar in the bar model represents the total mass of the jar plus all the quarters. So here's just the quarters, and here's the empty jar. So together, it's going to be the full thing. Okay. So let's answer some connect-it questions on page 619. Okay. I think you're centered. All right, number 1, the mass of the empty jar is blank grams. So looking on the previous page, there's a nice little picture there of an empty jar, and it says it weighs 400 grams. The total mass of the jar filled with quarters is blank kilograms. So this picture here, full jar, how many kilograms was that? That would be 1.5. Or how many grams? We converted it and we know it's 1,500 grams. Number 2, write and solve an equation to find the mass of quarters in grams. So that's what we did on the previous page, just taking away the weight of the empty jar. So 1,500 grams minus the empty jar, 400 grams. Which we found to equal 1,100 grams. So that's just the mass of all the quarters. Write and solve an equation to find out about how many quarters are in the jar. So that's the second part of what we did. We did 1,100 divided by 5, which equaled 220 quarters. Okay, so they're just having us kind of restate what we did on the previous page. Number 4, how does using a bar model to write an equation help you solve a word problem about mass? So this is your turn to check out this bar model over here in a little more detail. Figure out how this could help you solve the problem that we just did. And then come back over here to number 4 and answer that question for yourself. And the reflect question, the reflect, number 5. Which strategies do you like the best for problems about mass and weight? So do you like the pictures? Do you like bar models? Do you like the equations and stuff that we did on the previous page? Pause, write down which is your favorite strategy and why. For this one, I kind of honestly think that the pictures are pretty helpful because it's a complicated problem. They're telling us a lot of information up here, so the picture kind of helps break it down for me. At least that's my favorite, but you get to reflect on whichever one is your favorite and put that there. Okay, so once you're done with that, turn the page, unpause, and move on to number 6. Okay, number 6. A baker has one recipe for dinner rolls that uses 1 kilogram of flour. The baker has another recipe that uses 700 grams of flour. How many grams of flour does the baker use to make 2 batches of each recipe? Show your work. Okay, so the first recipe uses 1 kilogram. The other recipe uses 700 grams. And they're asking us how many grams of flour does he need to do 2 batches of each. So 2 of these, 2 of those. So there's going to be 4 batches total. So, and we need to change it into grams. It's asking how many grams. So I need to convert this 1 kilogram into grams. This 700 is already in grams, so I don't need to change that. So for the first recipe, 1 kilogram equals 1,000 grams. I'm basically just copying their little hint so that I can convert it. So that's how many grams is in the first recipe, but we need 2 batches of that recipe. So 1,000 grams times 2, 1,000 times 2 is 2,000 grams for the first recipe. So that one's done. For the second recipe, it was 700 grams. To do that twice, I multiply by 2. 700 times 2, you cover up the zeros. 7 times 2 is 14. Bring the zeros back in. 1,400 grams for 2 batches of the second recipe. Now I need to figure out how many total grams, so I need to add those together. So I'm going to stack them by place value. Make sure all my places line up perfectly. They kind of did already here, so I could have just added, but to make it look a little neater, do it over here. 0 plus 0 is 0, 0 plus 0 is 0, 0 plus 4 is 4, and 2 plus 1 is 3. Okay, so that's how many total grams of flour the baker needs to use. So, solution line. The baker needs 3,400 grams of flour total. Okay, so you can say anything like that, or they need this many grams of flour for 2 batches of each recipe, however you want to say it. 1 star for showing your work, 1 star for your answer in a sentence with a capital and a period. I miss giving you guys blue tickets. Okay, number 7. A can of nuts weighs 1 pound, 1 ounce. 1 pound, 1 ounce. The empty can weighs 3 ounces. Suppose you pour half the nuts from the can into a bowl. How many ounces are in the bowl? So, multiple steps here. Let's see, 1 pound, 1 ounce. So I need to convert that just into ounces. 1 pound, 1 ounce. So that's how much the full can of nuts weighs. But I need to figure out how much is that just in ounces. And they tell me 1 pound equals 16 ounces. So this 1 pound is 16 ounces plus the 1 other ounce. So the full can equals 17 ounces. Now the can, the empty can by itself without any nuts in it, is going to be 3 ounces. So I'm going to take that away from the full can. So 17 minus 3 equals 14 ounces. Okay, that's just the weight of the nuts. Now suppose you pour half of the nuts from this can, half of this, into a bowl. How many ounces are in the bowl? So what's half of 14? 14 divided by 2. 2 times what equals 14? That would be 7 ounces. So there are 7 ounces in the bowl. Okay, I went through that one kind of fast. If you need to pause it, rewind, redo that problem, go for it. It just wasn't too tricky. We converted the weight of the full can plus the nuts into ounces, and then we took away the weight of just the empty can to figure out just the weight of the nuts, and then figured out what half of that weight would be to go into the bowl. So 1 star for your work, 1 star for your sentence. And then we're moving on to number 8. Move my book up. Okay. Number 8. Tia picks 2 kilograms of strawberries. Yum. Her brother picks 850 grams of strawberries, and her sister picks 2.5 kilograms of strawberries. How many grams of strawberries do they pick in all? Show your work. In all tells me I need to figure out the total of all of those. So, and they want it in grams, so I need to convert everything to grams. So first I'll figure out Tia's. Can you see that? Yep, you're in. Okay, Tia is 2 kilograms. How many grams would that be? So 1 kilogram is 1,000 grams. That means 2 kilograms must be 2,000 grams. Okay, and then her brother, I'm just gonna write bro, equals, it says 850 grams. Already in grams. I don't need to convert that. 850 grams. And then, I don't know why I'm so squished over here. I thought I would need more space. Sis picks 2.5 kilograms. So 2.5 kilograms. So how many grams would that be? I know the full 2 kilograms equals 2,000 grams, just like Tia. But this half of a kilogram is going to be half of this. So half a kilogram is 500 grams. So she picked 2,500 grams. Okay, so now I know what Tia picked in grams, what her brother has in grams, and what her sister has in grams. I need to find the total of all 3 of those. So stacking them by place value. I'm doing them out of order just to make sure my place value doesn't get all wonky. I want to make sure my thousands places are right on top of each other. And then I'll put brothers down here. Or if you want to just add 2 at a time, you can. So let me double check. Got all my numbers correct. Yep. 0 plus 0 plus 0 is 0. 0 plus 0 plus 5 is 5. 0 plus 5 plus 8 is 13. And 2 plus 2 is 4. Plus 1 is 5. So all together, they pick 5,350 grams of strawberries. Does anybody else just call them strawbs, or is that just me? That might just be me. Okay. Star for your work, star for your sentence. Moving on. Practice page. All right. Okay, there we go. So on this practice page, the first problem is asking about the example. So this is the example problem right here. First problem says, look at the example above, so that's what I'm gonna do. The softball coach has a box filled with softballs. The weight of the empty box is 3 pounds. When it's filled with softballs, the box weighs 12 pounds. Each softball has a weight of 6 ounces. How many softballs are in the box? And remember, 1 pound equals 16 ounces. So this is just like our quarter problem, the first problem with the jar of quarters. This is just like the problem right here with the can of nuts. So first thing they did was find the total weight of softballs. So they took the weight of the box, the full box, minus the weight of just the box by itself to figure out 9 pounds. So that's just the weight of the softballs, it's 9 pounds. Then they converted just the 9 pounds into ounces, so they multiplied that 9 pounds times 16 ounces because 16 ounces is what 1 pound is. So this 9 pounds equals 144 ounces. Then to figure out how many softballs that is, because they told me right here each softball has a weight of 6 ounces, so they did 6 times something equals 144. But really, to figure out that n, your variable, you would do 144 divided by 6 equals n, which they found is 24. So they determined that there are 24 softballs in the box. So that's the example problem. Explain why you need to find the weight of the softballs in the box in ounces. So why do we need to figure out this part? Why do they convert it to ounces? Okay, so if you want to pause, think about it, figure out your answer, write it down, tell a friend, go for it, and then check back in, because my thought is that we need to convert the weight of the softballs into ounces because they tell us that each softball weighs 6 ounces. So they tell us the given weight is in ounces. And that's my explanation, the part of it. The given weight of a softball is in ounces. Okay, so you have to know the total weight of all the softballs in ounces if they tell you that one of them is in ounces. Then you find the number of softballs by dividing the total weight in ounces by the weight of one softball in ounces. And I'm just gonna go like that because I can. All right, number 2. Let's do some practice. Move you up a little. Okay. Tyson's baby brother weighed 7 pounds 3 ounces when he was born. What a chunker. The baby lost 9 ounces after a few days, so lost 9 ounces. Then gained 1 pound 6 ounces by the end of the 2nd week. How many ounces did the baby weigh at the end of the 2nd week? So the baby weighed 7 pounds 3 ounces. It lost some weight and then it gained more weight. So how much does it end up being at the end of the 2nd week? Okay, so first step, we need to convert its starting weight, the baby brother's starting weight, into ounces. Okay, so 7 pounds 3 ounces equals how many ounces total? So 7 pounds we need to convert first and then add the 3 ounces to it. So 1 pound is 16 ounces, 7 pounds is going to be 7 times 16 ounces, which I don't know that right on the top of my head, so I'm going to multiply on the side. 16 times 7. Okay, so 6 times 7 is 42. And this one is really a 10, so 10 times 7 is 70. 2 plus 0 is 2. 7 plus 4 is 11. So I'm not going to write that right there because that's just the 7 pounds. Okay, so then you need to add that 3 ounces to the 7 pounds. So 7 pounds by itself is 112 ounces, plus 3 more ounces is going to be 115 ounces. So that baby, when it started, when it was born, weighed 115 ounces. But then it lost 9 ounces. Okay, so 115 minus 9, that's supposed to be a 9, not a G, sorry, looked away. So what was its weight after a few days? So 115 minus 9 is 106 ounces. Okay, and then it gained 1 pound 6 ounces. So we want to add 1 pound 6 ounces to that. So go over here. They don't give you enough space on this one. 1 pound 6 OZ for ounces. That's how many ounces? Get over their work. Okay, so 1 pound is 16 ounces. I know that. Plus my 6 ounces. So 16 plus 6. 16, 17, 18, 19, 20, 21, 22. So the baby gained 22 ounces. So after a couple days, it weighs this much. Add the weight it gained. 106 plus 22. If you need to stack it by place value, do that. But when you're done, we need it, well, there's not really space for a sentence, so this is just going to be my solution. 128 ounces. I'm just going to circle this because they did not give us enough space on that one. So if you need to pause and organize your work a little bit, circle some stuff, underline some stuff, separate your work from the rest of your problem on the side, that'd be a good idea. 2 stars, 1 for your solution line, 1 for all that work. And then turn the page. Okay, number 3. There we go. Okay. Melinda makes 5 pounds of trail mix. She puts 4 ounces in each bag. She has 20 ounces of trail mix left over. How many bags of trail mix does Melinda make? So she makes a bunch of trail mix, and then she puts some of it into little bags, but she has 20 ounces left over after she puts a bunch in these little bags. So how many bags did she make? So there's a lot of steps. Here we go. First, we want to convert that 5 pounds into ounces to figure out how many ounces of trail mix she made. So 5 pounds is how many ounces? 1 pound is 16 ounces, so it's going to be 5 times 16. I'm going to do that one up here. If you want to count by 5 16 times, go for it. If you want to do 10 times 5 and 10 times 6 and then add them together, go for it. I'm just going to do this. 6 times 5 is 30. 10 times 5 is 50. 30 plus 50 is 80. Kind of got scrunched. 80 ounces. So that's how much she makes. But she's got 20 ounces left over, so I need to figure out the total amount she puts in the bags before that. So I'm going to do the 80 ounces she starts with minus the 20 ounces she's left over with to figure out how much she put in the bags. So 80 minus 20 is 60. So there are 60 ounces total in all the bags. But she puts 4 ounces in each bag. So 60 ounces divided by 4 ounces in each bag is going to tell me how many bags. Okay, so to do 60 divided by 4, I'm going to do a little area model over here. Dividend, divisor. How many groups of 4 can I take out of 60? I'm going to start by taking out 10 groups. 10 groups of 4 is 40. If I subtract, I'm left with 20. So I move 20 over. I can take 5 groups of 4 out of 20. No remainders. Add my partial quotients on the top. 15. So she made 15 bags of trail mix. I think my handwriting's getting worse. All right, star for your work, star for your sentence. Okay, number 4. Ooh, this one looks different. Okay, so they give us a word problem, they give us a chart with some information, and then there are just some yes, no boxes. So a large truck that moves cars can carry a maximum load of 15,720 pounds. Whoa, okay, so this giant truck, you know, you've seen those on the freeway, right? The big trucks, and they have like stacks of cars on top. So they can carry, at most, maximum, 15,720 pounds. So this table below shows the weight of each kind of car that could be loaded onto the truck. And they give us the hint that 1 ton equals 2,000 pounds. So a compact car, like a tiny car, it weighs 1.5 tons. So all these weights are in tons. So a compact car weighs 1.5 tons. A mid-size car weighs 2.25 tons, and a full-size car weighs 3 tons. So down here, we have to figure out if the combination of cars they give us is going to be less than this maximum load. Because if the combination is too big, then obviously the truck can't carry it, right? So if any of these, if we do the math and any combination is too much, then it's going to be a no. So if you want to pause it and try it yourself, go for it, using the information in the table and the hint that 1 ton equals 2,000 pounds. But I'm going to need some scratch paper for this, because where do they expect you to do this work, right? So I'm going to, I don't have a lot of space here. 2 full-size cars, 1 compact car. So I'm just going to copy some info. Sorry, I keep headbutting the camera there. Okay, 2 full, 1 compact is first. Okay, so looking at my table, the full-size car is 3 tons. Okay, so that's 3 tons. There's 2 of them, 3 tons and 3 tons. And then the 1 compact car is 1.5 tons. Okay, so if I add all that up, that's great. That's my weight in tons, but I need to convert all that to pounds to see if the big truck can carry this much, okay? So 1 ton is 2,000 pounds. So I need to multiply each of these by 2,000. So really, 3 tons, 3 times 2,000 is 6,000. Remember, pounds is LBS. And that same full-size car, that other 3-ton car, is going to be 6,000 pounds. And the 1 compact car is 1.5 tons. So that 1 whole ton is 2,000 pounds. Then half of a ton is 1,000. So 2,000 plus 1,000 is 3,000 pounds. So this is the total weight of those 3 cars, 6,000, 6,000, and 3,000. If you add all of that up, let's see, that together is 12,000 plus 3, 13, 14, 15. So all of that together equals 15,000 pounds, which is a lot of weight, but it's less than the maximum amount that the truck can hold. So yes, the truck can carry 2 full-size cars and 1 compact car because the weight is less than the maximum, so it'll fit, okay? So next one, 2 compact cars, 2 full-size. 2 compact, 2 full. All right, and then in my chart again, compact cars, there are 2 of them, 1.5 tons, 1.5 tons, and full size, 2 full size, 1 full size car is 3 tons in the chart, and then 3 tons. Okay, so there's my information laid out. Now I need to convert them to pounds. And guys, I've already done both of those conversions already. So 1.5 tons equals 3,000 pounds, but there are 2 of those. So 1.5 tons equals 3,000 pounds for that car, but the other compact car is also 3,000 pounds. And 1 full-size car is 3 tons, which equals 6,000 pounds, because 3 tons times 2,000 pounds equals 6,000. LBS for pounds, and the other car, 6,000 pounds. So 3 plus 3 is 6, so this is 6,000 plus 6,000 plus 6,000. If I add all that up, I'm going to be left with 18,000 pounds. Can that fit on the truck? No, it cannot. Okay. All right. Next one, 2 mid-size, 2 compact. 2 of those, 2 of those. You guys have seen my work to do those. So you are going to go through and do the same thing on your own to figure out these 2. This one and that one. Okay, so convert the weight in tons to pounds and figure that out, okay? Once you're done with that, once you have unpaused and figured that out, show your work to somebody, but you should get E and H. All right, and then number 5. A paperclip has a mass of 1 gram. A box of paper clips has 100 paper clips. Which equation below can be used to find the number of boxes of paper clips that have a mass of 1 kilogram? Let N be the number of boxes. And they tell us that 1 kilogram equals 1,000 grams. So it doesn't, oh yes it does. It says which equations. Okay, so there are more than 1. There are actually 3 down here. So there are 3 options that you need to find. So which equations tell us that, or will find the number of boxes of paper clips that have a mass of 1 kilogram? Okay, so that one's up to you too. Good luck finding all 3. Next lesson will be the refine day, so session 5. It's just all the problems. There are 9 on the next session, so it's just the last session of that lesson. So hopefully you guys are feeling okay about converting weights and lengths and volumes and everything, and just solving word problems, because that's all this lesson is. Hope you guys are doing great. Miss you lots. Bye.